All right, well, welcome to this session on how to build applications on the Algorand blockchain. My name is Russ Festino. I'm a developer advocate for Algorand. We have on board Jason Weathersby, who is going to also help out in the question and answer queue. So if you do have questions throughout this session, simply type them up in the chat window. And if you can do that in English, it would be greatly appreciated. If not, we'll have Hassan actually translate them for us. All right, so are you new to Algorand blockchain development? Well, possible solutions for blockchain is one of the things you want to look at, right? What kinds of applications can I create? So that part of the session will give you some ideas in terms of the solutions. I know when I first started learning Algorand blockchain, that was a question on my mind, as well as, what are the features for developers? What would the developers look like? And the toolbox, what's in my set of tools here that I could use to build Algorand blockchain solutions. As in any great new technology, there's always a third-party market and a community part to the market that develops solutions and tools and SDKs and all that kind of good stuff. And we'll take a look at that here today as well. And how about just simply, how do I get started? And as well as, building solutions, how do I build a solution? So if you are brand new to blockchain, there's a video I'd like you to watch for a homework assignment. And this has a good kind of general intro to blockchain in general. And it's up on our Algorand channel on youtube.com. So I invite you to go ahead and look at that as well. So here's the agenda for the next hour and a half. We're going to go look at blockchain use cases to start out with. We've got layer one features built right into the blockchain. Lots of those that developers would be very interested in, as well as a lot of tools we'll go over. So I do have a little contest here today. If you sign up for our developer newsletter, which you want to do anyway, we're going to put you in the running for a an Amazon gift card. I also put that link right into the chat window as well. So we'll do a drawing at the end for that, and there'll be a $100 Amazon gift card. It is a great newsletter. You can see a sample of it up there. It comes out every weekly basis, and tells you what's new on our site. So you want to be in the know on that one. All right, let's get into blockchain use cases. So the first one we want to look at here is crowdfunding. And the traditional issue here, it's hard to get traditional funding. Lack of trust among participants prevails. You have investors that need to trust the inventors, and then you got the inventors that need to trust the investors, and many times they don't know each other, from Adam. So it's really good to have an audit trail as well. With a lot of types of applications, actually, not just crowdfunding, because you want to know where the funds came from and where they're going to. So the solution is that blockchain makes this funding process safe and secure. Yes.
Fustino diyordu.
All right. So, Hassan, can you mute some folks that are talking if you can? Appreciate it.
Sorry, okay.
All right. Blockchain makes this funding process safe. It offers transparent access globally. So there's no boundaries involved here. This can be done and from anywhere on the planet. Provides a secure, automated approach to crowdfunding, as well as you can define computer code, right, for the terms of agreement. In other words, a smart contract of some sort. And then, providing an atomic transfer. You don't want the funding to go through unless the goal has been met, right, to exceed a certain amount of dollars. Otherwise, everything will go back to the way it was. And that's what atomic transfers are all about. And that's facilitated by the blockchain. Investors raise funds in hopes of success, and they get a return on investment. And it's really a new skyline for many investors, is to use this approach for crowdfunding. So, new way to raise funds. And the next issue an area of supply chain management. So any kind of supply chain scenario is a very good one, right, for blockchain. Traditionally, this has been difficult to manage with the overwhelming amount of information in the flow of the entire process. Lots of materials, financial capital, coordination among multiple stockholders. There's a lot of things that are taking place here and need a good solution. So with blockchain technology, this enhances the efficiency and the transparency. In other words, you can track everything from warehousing to delivery. In the old days, you might have a lot of a paper trail, right? Sign-offs, you sign off as soon as something comes off the boat, and then it goes to the warehouse, and then it goes to the manufacturer. Well, data is more interoperable with blockchain, and you can share data, and information a lot easier to suppliers, to manufacturers, to vendors, and it is tamper-proof. So that's another key area. We've already seen just in these two key, examples, decentralization is a theme, and tamper-proof and audit trails is another theme. So those are two things to keep in mind here with the Algorand blockchain. And this establishes trust. Another big area is the gaming industry, and the gaming industry will facilitate gamers. And right now, the state is the gamers are at the mercy of the game developers, right? Players are bound to the developer server space. Developers, change the rules of the game. Developers hold the power to change or remove items. So you could be spending a month and earning some, points in different aspects of the game, and all of a sudden it just goes away. So players are merely, licensees is really the bottom line there. So the solution, things like Gods Unchained, right? This flips the script. That particular game actually gives you crypto tokens. And the gamers actually own those assets. So once they got them, they don't go away. They're in their possession. The player is in control of the ownership, the management, the maintenance, and it is globally available. So if you go on a vacation somewhere, another country, or whatever, you can still get at those because they are globally available. And we are going to talk more about crypto tokens and how you can create your own in Algorand in the way of Algorand standard assets. Another area that really is a great solution for content entertainment is the distribution of things like copyrighted materials. And the challenges with the traditional content distribution are it's not a decentralized approach. There's a vault somewhere, with a data store or multiple data stores that have a lock and key on it. And what happens to the centralized data centers with the lock and key? Well, just about every day you hear about a security breach in one aspect or another. So this is really, something that's happening at a higher and higher rate. And we really need to address this in the solutions that we're building as developers. Very difficult to determine which artists are affected. A lot of times there's multiple copyright holders, as well as lack of sales transparency. Again, the audit trail, right? There's a lack of, tracking where these funds actually were. For those that are brand new to blockchain, really what it is a distributed ledger or distributed database you can think in your mind. And basically it's a read-only, write-once database. And every block that's written has a bunch of transactions that are associated with it. And so this block is when you write out the transactions into the chain. And then they have a hashing algorithm between blocks that really detects the tampering, that could take place in a data scenario. So very, very secure and tamper-proof. So the solution here along this area is with blockchain eliminates piracy via content copyright tracking. It's a lot easier to track it once it's on a blockchain. All transactions are recorded in the ledger. Everybody can see those transactions, and then offers a personalized content experience as well as provides opportunities for seamless payments and transactions globally. So a few other use cases, you can see here, we've got tamper-proof charity organizations in China, for example. they're using blockchain to improve the transparency of social services and tracking of donations. Back, I think about 10 years ago, when one of the earthquakes hit, there was a lack of an audit trail and to exactly to where the funds went to. So charity organizations now can benefit from this audit trail. Voting, boy, we got a big vote going on right now here in the USA. And by the way, if anybody hears of an official winner, just butt right in and let me know. We're all on edge of our seats here to see who won the presidential elections. They're still counting the votes right now. But anyway, this is a tamper-proof approach to creating, a data store of votes. So again, something to consider going forward, and any voting applications you might write. Again, another great use case scenario. And finally, the automotive industry, right? The supply chain visibility and vehicle integrity is built right in. In China, they're actually putting sensors into the engines there that will track the wear and tear of the spare parts and give you a good readout in terms of what the automobile has gone through in the state of that vehicle. And not only that, it gets better, right? DeFi apps are exploding in 2020. There's over $20 billion of crypto dollars and stable coins floating around. For those that are unfamiliar with stable coins, it's basically an asset that you would build on a blockchain that is tied to a fiat, like a USD arrangement. So one of the big problems with cryptocurrencies has been the fluctuation of the value of those assets, and this kind of like stabilizes it, i.e. stable coins, by tying it more to a real world economy. And examples, lots of Algorand DeFi examples. Now we're hitting a lot of the Algorand use cases here with IDEX and Monerarium and stable coins like Tether, USDC, MELD. These are all out there. In fact, you can see a lot more of these use cases up on the Algorand website. Things like, asset block is tokenizing real estate assets. So if you have a large hotel and you want a piece of that hotel, you can get it now. You can invest in it, through those type of solutions. And then the whole ecosystem is just exploding with Algorand. In terms of the technical companies up in the upper left, we're going to take a look at a few of these here today, like Algo Signer, and you've got a few explorers out there we'll be looking at. But this is what I was talking about. There's a lot of third-party solutions that are being created out here from a technical standpoint. A lot of SDKs out there. You've got not only the ones that Algorand supports, but there's some community-supported SDKs that are out there, like C# and Dart and Rust. So lots of growth here. And then the financial infrastructure, a ton of companies that are really engaging here with the Algorand ecosystem, as well as all the applications now, the solutions that are being built on the bottom part of this slide. It's really not bad, right? For year one of Algorand, we went mainnet back in June of the year prior. We're looking at over 500 companies now leveraging Algorand's platform. We're on 60 global exchanges. There's a lot of wallet providers. We have over I think it's actually, I got up this slide, it's close to 500 ambassadors. Those are like our MVP folks. Hassan's one of those. And if there's any other ambassadors here in the group, please chime in on the chat window. Let everybody know you're an ambassador for Algorand. And, by the end of the year, we're looking at tracking 10 million users on the chain. That's a freaking amazing. So a lot of a big success there. So let's take a look at our first demo here, and we're going to take a look at crypto tokens like we talked about. And there's a tool here called AlgoDesk that is a pretty cool tool. It has both an application manager as well as an asset management functions. So there's a Teal IDE editor. Teal is our language that we use for smart contracts. But here what we're going to show you is our asset management. And the first thing you would see here is a mnemonic. This is, in other words, this is a private key that you can use for sending assets. And so you'd want to copy that off because you may need that to restore your account at some point, or you know, if you get a wallet, you have to, you know, type in a phrase or whatever, and that'll go ahead and reconstitute it. So let's get started. We're going to create a brand new asset here, and let's call this Russ. Give it a unit name of Russ coin. Let's go to a total supply, let's say 10,000. You can have a decimal point there as well. You could say, okay, I'm going to say a decimal point of 1. So that really means the total supply here is going to be 1,000.0. Also, you could specify a URL. And I know some folks that are using this field to integrate with IPFS. So if you have to like point to a large digital asset, like an image or something like that, you can do that through wiring it up this way. And then I'm going to keep all the defaults, but I do want to point out a few of these fields on the bottom here. One of them is a manager address. This will facilitate all management functions, and these are all changeable. You can have the creator has the initial set of these all set to this HGB account, which is your new account that we just created. Also, there's a freeze address. So this will facilitate freezing functions. In other words, the asset cannot be consumed or traded from a particular account. There's a reserve address as well as a clawback address to claw back funds if you need to, maybe in a game or something, you got funds that need to come back. So these are all programmable. These are all available in the SDK. But I'm showing you the visual version of this because this is a very nice tool and very useful for developers if you want to go ahead and start testing assets and using those in your application. So there it is on the bottom. You got the Rust coin created. You've got, it looks like we had the decimal point after those 10,000 with this IDE. So a little bit of a correction there. So it's 10,000.0. You also have, we can open the asset in the browser. I'll do that in a second. But you also have a lot of functions here in the way of sending assets. Modifying an asset would be modifying, for example, who is the manager. So you can assign that to another account. Next area on layer 1 features. So we'll talk about Algorand standard assets, as well as atomic transactions, Algorand smart contracts, and rekeying. So the pure proof of stake protocol is the first thing we'll take a quick look at. For those that are not familiar with our protocol at Algorand, it provides true scalability. It scales to billions of users. Also provides infrastructure longevity. It's open sourced. And once that is the case, then now you can actually see the logic that's used to create the blocks in the chain and really have all that source code available to you for whatever reason that you want. Technical flexibility, we've rolled out several releases and upgrades. Really, the users did not know, really didn't impact or have any downtime on that, as well as having ability to create both networks in testnet, betanet, mainnet, and as well as a private network that's like a personal network you can do. So lots of flexibility there. Transaction certainty is really huge. This is instant transaction certainty. There's no forks on the blockchain. Blocks are created in under 5 seconds, and that's improving as the time goes on. Right now, this is a very big feature for solutions that you're building because it does facilitate things like point of sale types transactions, whereas other blockchains may take 10 minutes, right, to go ahead and do the same type of thing of writing a block out to the blockchain. Platform extensibility, lots of SDKs, a lot of third-party tools, community tools, extremely energy efficient. You can run this on a Raspberry Pi, a node. Also, it's very cost efficient, less than a penny a transaction. True security. So I had a cybersecurity expert in one of my sessions, and she said, the way to kind of simplify how secure a blockchain is basically, what two-factor authentication is, where have them, whatever the service is, text you back to your cell phone to prove it's you to go in. Well, you kind of multiply that times the number of blocks in the chains, and that is how secure this is. So it really is tamper-proof, and that is a big strength for the Algorand blockchain. So we took a look at creating an asset with standard assets and ASA, create native tokens, as well as what we did here. And then also we want to take a look at, you have the ability to have administrator functions. And so, so you can create your own token, right? Your own asset, whether it's for a game or whatever, or your own coin. And you can do that with ASA. Also provides asset spam protection, where you cannot have a spammer just automatically sending out assets to everybody on the planet. You have to opt into that particular asset. So more explicitly, the fungible tokens, which we have here, are one type of example asset. This could be in-game points, stable coins, loyalty points, cryptocurrencies fall into that. You also have restricted fungible tokens, and that would be in the way of securities, government issued fiats perhaps, and anything that involves a clawback capability there. Non-fungible tokens would be like in-game tokens. So these are things that are not exactly the same. Fungible tokens are, each token is exactly the same, represents the same exact thing. Whereas non-fungible would be like real estate is a good example of that. You can have a piece of property, a 4-bedroom home, and two different sides of the street, and one would be worth more than the other because there are other intangibles that go into that particular home. So that is a good example right there of doing that. And all you do is create a supply of one, and then you have yourself a non-fungible token. Then we got restricted non-fungible tokens with real estate, once again, ownership registries and regulatory agencies. That brings us to atomic transfers. This is really a great feature. All must succeed or all fail. So in the example on the right, we got person A is going to send 50 algos to person B, and then person B is going to take this concert ticket and then get it back to person A. So this transaction, it all happens or none of it happens, right? So if the person B doesn't receive the 50 algos, all bets are off. If person A doesn't receive the concert ticket, all bets are off. So this is a way of actually doing transaction between parties that don't know each other. And you have on-chain native functions, easy and secure. It's up to 16 transactions you can do in an atomic transfer. The very important point about atomic transfers is you can wrap a lot of other functionality into an atomic transfer, smart contracts, ASA, a lot of capabilities here, all wrapped in. I'll talk more about that as we go on. And this guarantees an exchange of goods, and you can combine it with other technologies like I just referred to. Examples of atomic transfers would be simplified, expedited settlement statements, efficient matched funding, reduce counterparty risk. You can enable any multilateral trade. Circular trades are a big item, go from 1 to 2 to 3 to 1. Group payments, very popular as well. Combine ASA with smart contracts. You can have instant settlement for complex multi-party asset transactions. And then distributed payments as well. That brings us to smart contracts. So Algorand smart contracts provide the ability to have transaction execution approval language, or TEAL. There is a Python-enabled compiler that compiles the Python into TEAL source code. And there are two types of smart contracts we'll be talking about here. Stateless, which approve spending transactions. And then you have stateful, which is a global local storage capability on the blockchain. The local storage would be on the user or the account level. Global would be available to the entire blockchain, that particular field. Then we get smart contract value in the finance industry, basically trade finance, clearing and settlement, financial data recording, digital identity. These are all big items that provide a lot of value when doing smart contracts. In the DeFi area, you've got escrow accounts can be set up, payments can be set up, credit and lending, as well as stable coins. So these are all big things that are happening in the finance industry, which is probably the biggest use case for blockchain. Algorand accounts. Let's talk about accounts now, where we have standard accounts, multiple signature accounts, and then logic accounts. The standard account, you notice there's a pair of keys there, right? So every cryptographic key pair consists of a public key and a private key. So the public key is available to everybody. That's what you use to receive funds or receive assets. The private key is used to sign off and send assets, and that is private to you. Only you have that particular key. So what this really represents, this slide, is how you sign a particular transaction. You can sign it by a standard account. One account can sign it. To send out monies, you can create a multi-signature account. This is like a check that you cash at a bank that has 2 signatures that are needed in order to cash that check. In that case, the threshold would be 2. And so you would have 2 signers right on that, being able to make that legit. Same thing here with a multi-sig account. If you got, here's 3 in this multi-sig account, 3 accounts. And if any 2 of those vote, you would specify the threshold equal to 2. And if that happens, then you can send funds from that multi-signature account out to whoever the transaction would go to, because it's been approved. Similarly, a logic account is a smart contract, and if that returns true in its simplest terms, then that will facilitate the signing. And that is being used more and more in a lot of different solutions. It's also a new feature we just came out with recently, about a month ago, called Reking. Up until this point, it's been difficult to separate the public key from the private key because it is a cryptographic key pair. And like I mentioned, the public key is used for receiving funds and the private key is used for sending assets. So what rekeying does is it separates those and assigns another authorized address to approve the transactions. In other words, sign it. So on the left, what you see here is basically you've got the paired private and public. You uncouple those, and then you can replace the signing. In this case, this is going to be using a multi-sig. So maybe you're growing from a single signature to a multi-signature, or you want to replace it with a smart contract. And so now you can facilitate that very, very easily. And it's even supported right in the Algorand wallet, which is showed on the left. The way it looks in the data is actually an additional field here called authorized address. So that is authorizing this NFF account to be able to sign off on that particular account or the spending key. All right, so here's the scenario, right? When we're combining layer 1 features, and this is what we had started to allude to, right? So you have a voting commission, for example, in a voting example with a spending token that goes out. Now, what you want to do is wrap this into an atomically grouped transaction, because you don't want this thing to succeed unless this candidate actually votes. And then the smart contract will determine, okay, yeah, this is all legit. I'm going to increment the candidate vote total, and that goes where? Into the global state. So now we have several pieces of technology. You might be using ASA to create the tokens. You would be using atomic transfer to do all the transfer work. You would use the smart contract to verify that this is indeed correct. And then you're using a smart stateful contract to go ahead and write this out to global state. Another example would be crowdfunding. If you're considering doing something like a crowdfunding type solution, same type of thing. You start out with a stateless smart contract that will issue the payment from escrow to the user. Again, you're going to atomically group this, and then user 1 claims the escrow funds via a stateful smart contract. So here we're combining stateless with stateful. We're also doing atomically grouped, and we're using, we could use a payment, could be any form, right? It could be algos or it could be assets that you could be sending here in this scenario. All right, we got any questions worth sharing here with anybody? All right. All right, so let's go ahead and continue here. We got Algorand developer stuff. That's the best part of the session here today. So you got protocols and different versions that are being used, and typically new protocol versions would be facilitated through BetaNet testing. And so that's what the purpose of BetaNet is. Testnet and mainnet mirror each other. So if you write an application, you test it out with testnet, you have exactly the same environment on mainnet, same protocol, same release. Then you also have private networks at the bottom, like I alluded to. This is like a kind of like a personal network that you can create for whatever reasons. That is can replicate any one of these particular environments. So give you an example of that. Whenever BetaNet is in flux and we have a lot of rapid changes coming out in a new protocol, sometimes I like to test one out. So I'll basically create a snapshot of that in my private network. And this way, if BetaNet does get updated from underneath, it will not affect my testing. I have a solid test base. So that's a good use case. All right, so then we get the developer portal, and we got developer.algorand.org. So let's go ahead and take a look at that. Or that just happened D and it comes up. How about that? Lots of great content. Here's an example, digital exchange a contract, a DEX application. Here's another one, how to get started with Android. So these are kind of the recent ones we showcase here on the left, but on the right, on the left side, you can see the different categories. We got tutorials, you've got solutions. There's some of the tutorials that are in here. You've got some solutions. Crowdfunding, right? There's a solution on the crowdfunding application. There's another one down here on the voting. I wrote one here on how to build a iOS app with Android and for Windows, and that's using the C# .SDK and Xamarin. By the way, that C# SDK, I believe, just got updated today for version 2. So that's another thing I got to check out and test. And then also you have articles that get published all the time. So we have a lot of great, like here's an article on connecting web apps using AlgoSigner, like I just showed the demo on that. The documentation is the key thing I want to show you here. So when you want to get started going, this is the section you want to go to. You want to start the building. You want to do this workspace setup, connect to a node, and do your first transaction. So very, very step-by-step oriented. You should be in good shape. And then explore features is another area you want to look at. If you're looking to do, for example, ASA or assets, here is an example page that does all of this and talks about the reserve address, the freeze address. And then we got code snippets right down below. So this is creating an asset is this particular function and how to do it in code. And you can see you've got examples in JavaScript, Python, Java, Go. Those are the 4 supported SDKs by Algorand. Also, we have a command line tool here that is available to be used as well for you command line experts out there. And these are all displayed very nicely. And then also a lot of these have the source code available at the bottom. You can see there is the link to the examples. And you can bring this up, and V2 is the current version. And then you have these all by language. So this is by, getting started here, examples. And then you can see there's the asset example that you have that does everything. So that's kind of the lay of the land on that. And then we've got, to continue on here. Talk about nodes. I had mentioned that in the startup process. So you can create and run your own node on a Mac, Ubuntu, and other Linux distros. Also, I think we're working on a new platform, a couple new platforms. You've got Mac OS and Windows. I just saw that get merged into the code base, the pull request. So I'm not sure if it's made its way out in terms of SDK availability or not, but that is on the way if it's not there already. It's another thing on my to-do list to take a look at. Jason, I don't know if you have any updates on that. You can speak right up if you want right to now, otherwise I'll keep going.
Yeah, no updates right this minute.
Okay, great. So also, it's very fast now to catch up. This used to take several hours when you were building your own node. Now we have a fast catch-up feature. So instead of taking, 3 days to build a node and have it all on your particular node, you can use fast catch-up and it'll be caught up in a matter of minutes, like 5 minutes, and you'll be all caught up. PureStake and RAN Labs have API services. So if you don't want to run your own node, basically you can use theirs. That's a simple way to put it. It's indexed, it's archived, you know, and you know, I'm going to talk about an indexer feature which needs the archive turned on. So they've already done that, and normally that, again, it would be like a 3-day process to build a node with that type of intent. This can be accessed from any SDK code on all the platforms, and you know, it could be Windows, could be Mac, could be whatever. So this is available to use globally. And I like this solution when you're building mobile apps, because you don't have local hosts on your machine. You would have to have a stand-up instance somewhere to point to for a node in the code that's running on a mobile app. So this is a good solution for that. The best thing we got for developers going is the bottom one here. This is the sandbox. It's a Docker instance. It's not for production. It takes a snapshot of the current node, and there's no sync time. So you are up and running immediately. And this is what I use for a lot of my demos. You'll see here that this is the GitHub repository for that. There's a tutorial, very easy instructions to get going on it. And we also have some documentation on the developer site. So let's take a look at this right here. So if I bring up the sandbox right here, you can see what I did here. I've got the node address available here in the README file. So this is all you need when you go to create applications. You need to have the address with the port number and then the token, and they're listed right in the README file. So a lot of our demos are preceded with these values. So because most of our developers default to creating applications with the sandbox. And that's it. And then you can see down here is the terminal. So all you would do is at the very bottom of the screen, do a .sandbox up testnet, and that would bring up your instance. You can also do goal commands. Right, you want to get a status on the node, or go ahead and bring it back. You got to, you know, this is the block number. 0 sync time is what you typically see there. So this is our sandbox, and again, you'll see these values in some of the code we're going to be showing in a little bit. All right. Then we got SDK functionality. Like I mentioned, a lot of standalone functions. You can create accounts, do account mnemonics. It supports creating transactions, signing transactions, and then broadcasting the transactions. So 4 native SDKs are Go, Python, Java, JavaScript. Then the community SDK, an example here is a C# SDK available. That's what I use to build that Xamarin app I referred to before. And then you can install and instantiate the SDK guide with the JavaScript that you see here present with, you just go ahead and do the install. You can verify it with the NPM list. And then there's examples in code on that page on how to instantiate those. Couple dispensers. One is when you create accounts in testnet or betanet, they'll need funds because every transaction needs a fee, right, to be associated with it. And so those are dispensers that will get you going in that direction. So let's take a look at our first demo here in code. I'm going to go ahead and bring up, they're going to start out with Java. And this is going to be simply creating accounts. And I've got a breakpoint set. So I may just run this in the debugger. And I should stop on this last print. There it is. So now I'm starting to print out the information down below in the console. What I would do is just let this run to completion here. And then you can see I've got all the mnemonic phrases and the accounts. So what you would do is take this account, for example, copy it off, go out to the browser. And then bring up the dispenser. And then go ahead and dispense the funds to it. So 200 status is great. So now that money has been dispensed, you can actually look at this transaction ID again, one of the explorers, and verify that. Then the first transaction. So now we've got accounts set up, and then you can see here the port number, the token, the local host that I referred to for the sandbox. we're going to go ahead and create the client, and let me just run this and go to my breakpoints. So the first breakpoint I've got is this actual, this is the transaction method for doing a payment, this payment transaction. I've got a send address and I've got the receiver address up here. I also got a string field for the note field that you can specify any structure in. So it's a good way to, you know, utilize the note field to whatever accommodate your need. We have a chess playing example, for example, where we store the state of the game in that transaction in the note field with the structure. Other ways to do that now, of course, with you know, smart contracts and the like, but there is a wait for confirmation method I've got to point you to. What that does is if I hit the run key now, it's going to do this transfer. It's going to transfer 100,000 micro algos. And right now it was signed, you can see down below, and then you can see the wait for confirmation. That's the 5-second wait for the block to be written, and that was successful. And this is the information down below that shows the transaction ID, the transaction information right down here, as well as the decoded note for hello world, and then the balance. So you can see the balance we started up here was the 21,725, 399, and then we got the 21,7, and then you got the 100,000 more than that, so you got the 251 instead of 252, and that's it. So those are the balances. So that's your basic process. So to review here, important steps. Number one, you do the transaction. Number two, you sign the transaction with the sender account. And then number three, you broadcast it to the network with this send, this raw transaction send. This is where you would typically have errors if there was insufficient funding in the account or double spending or whatever the protocol will detect. If you get a clean send, it's been successfully sent. And then you can see the wait for the confirmation there is the last piece. We are polling the pending transaction information to get the information about the notes as well as the entire transaction that we have there, and that's what we're printing out in the end. All right, that is that transaction. Now, what I'm going to do is show you a few more with multi-sig and atomic transfers. So let's go ahead and bring that up. So for this one, we are going to use Python. And I'm going to bring up this app. I'm just going to go ahead and run this, and we'll discuss it on the breakpoints that I set here. Oh, I got to launch the Python file. All right, so we hit our first breakpoint, and what we've got here is basically we've got two accounts we're specifying in the multi-signature account, and we are setting a threshold of 2. So this means that both of the accounts need to sign off on this for this to count. We can add a comma account 3. I've got 3 accounts in this example that we're restoring up here on the top. So this takes those mnemonics that we talked about, and for testing purposes, you can go ahead and restore those and have those in your account. And then what we're going to do is we're actually going to send the funds to account 3 here in this demo. So this creates a multi-signature account. So if I step over this, this is the multi-signature address that you see now in the debug console. And what you would see here is where to go ahead and specify the account, right, that you want to make sure is funded. This RBS fund, you would need to go out to the dispenser and allocate the funds to that account, make sure you've got enough in there for testing. Now we've got the sandbox. Go ahead and instantiate the client. So that's going to take the token, going to take the address. And then you got suggested params that you can get out of the params field. But here's where the important part is, where you're going to sign both these transactions by private key 1 and then private key 2. So that makes sense. And then we get down to the actual payment transaction, paying from the sender to the recipient. And we are going to be taking that transaction and taking the multi-sig, and now we're going to basically run this through the send the raw transaction out to the network. So that came back true. Along with the signatures, it will go ahead and process this. It's waiting for the confirmation, and there it is. It was sent, so that was successful. The next thing on our demo list was atomic transactions. So let's go ahead and take a look at the atomic transaction. This I'm going to show you in Go. So this is yet another language that we support. And for the Go programmers out there, what we're going to do is basically wrap 2 pieces into this transaction, and both have to successfully execute. So let's go ahead and hit our first breakpoint here. And we're going to display all the initial balances in the output window. You can see right down of the 3 accounts that are in there. Then I'm going to do the first piece, which is I'm going to create the transaction. So we're going to do like this scenario. We're going to transfer from account 1 to account 3. And then also the second piece of this is we're going to transfer an amount from account 2 to account 1. And the amount of the first transaction is going to be 1 algo, and the amount of the second transaction is going to be 2 algos. And then we're going to apply the transaction fee, combine the transactions together with this group ID. Let me just get down to that point. And so now we've got those all grouped together, and there's our signed transactions. We're going to go ahead and create one for the first and another one for the second. And those are going to be appended into a signed group byte array. That's what we're going to use to do the signing of the group right there. And that's how it works. So now we're waiting for the confirmation to come back. It is successful. And we print out the information down below with that particular transaction. All right, and the crowd goes wild. All right. Go out to the next level here. And let's get into the smart contract piece of this. So Algorand Stateless smart contracts, it replaces the signing of transactions. You have 2 types, a logic account. So any transaction sent from this account will be verified by the predefined logic, like you would think. This is great for escrow style accounts, split payments, hash time lock contracts. And also you have a logic signature. So it does the same thing, but it also needs a signature or a delegated authority of another account. So in addition to it returning true, it has to be signed off by another party. So this is good for recurring payments, for example. So let's take a look at the contract account, and let's go ahead and bring up the demos again. And for this one, let's go take a look at our contract account in Python. So I'm going ahead and run this, and we'll take a look at the code as we run through this. All right, so the first thing we're going to do, we're going to actually just have a simple teal program, and which has just a few lines of code. It's going to take an argument, it's going to compare it to the argument and see if it's equal to the value of 1, 2, 3, like you see in the comments here. If they are equal, then it's going to return true. So we're going to set up the argument here that we're going to pass in as 1, 2, 3. We've got the logic signature now that's going to sign that based on that argument. And this is going to give us our address, and we're just going to do a transaction based on that. So if it returns true, then it's going to be successful and create that. So it's waiting for the confirmation now, comes back, returns true. The other one I refer to as account delegation. It's exactly the same thing, except there's one additional step in here, and that's where we have a secret key from an account that's also going to be added into the mix. And you can see right there, we're going to get that secret key for that, and we'll be able to sign the transaction with that as well. And so that will get down here at the bottom, and that will go ahead and that gets wrapped into the LSIG there with the signed transaction. So both the contract has to be returned true and it has to be signed. So that is how that one works. All right, now the really, really, really good stuff. And this I love. So this is the stateful smart contract lifecycle. Let's talk about first. Several pieces of this. You can create an application. That'll be the first step you would need to do. And then opt in, just like we saw an opt-in caseability with the assets. You have an opt-in to participate. In other words, you're going to say, okay, I want local storage. You know, this user account can use their own local storage. Then you want to call the app. This is a no-op, and typically your contract would have logic in it saying, okay, if this is a no-op, just execute it. And if not, don't do anything. But that is what you would want to do is you want to call it. Then update the application is a possible scenario where maybe you've got some changes you need to make to the contract, so you can update the application. Once it's all said and done, you can delete it. That is both the update and delete and create all need to be done by the creator account. And then close out. This is a teal logic. This must be true. So this will close out the account and reset the global variables. If the transaction returns false, however, it will not do the closeout. For the what you have to do is a clear state, and this will always clear the user account. And typically after you close out, even if it does go true, that's just clearing the global. What you need to do is clear the state from the user account. So the closeout would be done by the that would be done in the logic, and like I said, and then clear state also will be used to clear the state for the user account. This is a great link to look at. I go over the life cycle there on there like we just talked about. Nice diagram in terms of going, but the part I want to get to is right down here. There are examples in teal, which is a stack-based language, but also the PyTeal that would generate that. So this is very useful when you're starting to create your scripts. And if you know Python, you're good to go, and you can go ahead and do this in a higher level language for the most part. So anyway, I just wanted to call that to your attention. And there is the PyTeal. We'll talk about that next. So basically, this is an example of the PyTeal. You have a compile teal function, which will generate the source code. Notice the mode here is for signature. This is a stateless contract we're creating here, and it will return the actual source code in teal by using that. The next example here is using creating a new application. So this would be used for a stateful application where you go ahead and create doing your approval program. This is the PyTeal. It's actually only got one line in it, which is going to increment the counter here. Run that compile teal can. Note the mode now is mode application. So this is going to still use this compile teal command that generates the source code for the teal. Then what you need to do is use the STK compile function on the client, and with that source code that you see right there. And that now can be used as a parameter into the application create. So you need to have the compiled version of that in the to go ahead and create the application. Next up is a very good topic. I'm going to tie all this together in the next demo, is debugging. And typically what you want to debug are the accounts, the signed transactions, and the source, right, to step through it. You take those three things and you create a dry run request. And the dry run request is used with the teal debugger. And this is the file that it looks like. It's stored as a byte array, but then if you unravel it, this is the JSON of what's actually included. So you would see things like in there, the accounts, the signed transaction information, everything you would need to do the debugging with. Then what you do is invoke the Chrome inspector and inspect method. And this is where you just simply configure it to the correct port that you would need. And you can step through it right through with the debugger with breakpoints and everything. So let's take a look at this demo. I'm going to bring this up. All right, so I'm just going to run this. You can see all of these steps. This is in Python. All right, so the first part we want to do is define our local integers and our variables. Right? They're going to be used in this application. Two data types. One is int, the other is bytes, a byte arrays. And this is going to be a very simple example. We're just going to have a local counter and a global counter. So I'm going to need one of each. Those are going to go into the schema, and now that's available for subsequent calls. I've got two accounts I'm going to work with. I'm going to have a creator account and a user account. And so that is all set. And the next thing we want to do is provide our approval program. And there's the one line of code where we're going to increment the global counter. And then we're going to show you how to do an update. And what I'm going to do is call that approval program refactored. And this is where I'm just adding in a second line here, which is going to be updating the local counter. All right, with me? So then there's a clear state program that's used in the call to create a program. And here is the compile teal method that we have on those three sets of sources. So I read those in, compile the teal, and now I've got three files that will get generated. One will be the hello world teal, which just has the counter and the global gets and puts, and then the updated one will have a little bit more in it, right? This is what gets generated in the application. All right, and then we're going to compile the program. So I have a breakpoint set in this routine, and so now we're going to use the compile method on the program source and return that back in our base 64 decode bytes array. And I'm going to take that off and just run this again. And so now we can create the app, and that's the first step in our method. And so with creating the app, we're just going to use the application create transaction method. So I'm in the routine here for create app that you just saw. Sign the transaction, send the transaction, wait for confirmation. So all this is should be familiar with you, and it works the same way here. And what you're going to get out of it is the application ID. So that's what we see get printed off down below here. So now we have a new application ID, this 130-78790. Next up is going to be to opt in. And so this is going to opt in. And by the way, you can see the creator key up on top does the creation. We're going to use two calls here. We're going to do one of these for the user, one of these for the creator. The user is going to call the application with just the global state. So we're going to print that out and show it to you. Then we're going to update the app with the updated program that has the local state in it. We're going to call it again, and then you'll see the local state variables be done. And then we can opt into the application after we've closed it out. That's entirely possible. And then you can see the call app right down below here. All right, so let's go ahead and run this, and you can see this in the debugger. All right, so now we've got our waiting for the confirmation for the first one. And now we're going to do the opt-in on the second one. And now we're going to call the app. This is where I have the debugger set up. So I'm passing in the first parameter, which is the first program, which is the global update. And now you can see I'm going to get the dry run information. So with the dry run information, you have to have the field name set to approve. And these are the accounts that I'm passing into the dry run, like I had mentioned. And I'm going to take that off, go ahead and run this. And then we got the call now to the teal debugger. I'm doing it through the execute command. This is a command line utility. But this is also nice in terms of how you use that. Now, so what I have to do is go out to Chrome, to the inspect, copy this out, and bring up my browser. Okay, and let's go ahead and put this in here from inspect. All right, so the first thing you would do is configure this, make sure you set the 9392 as the port. And then let's go ahead and inspect that. And now you can see the debugger actually come up and we can step through this. And what we can see here is you've got global variables, there's the counter, and then you have local variables, which won't get updated just yet. There's the stack, which is very important. It tells you the current value at the top of the stack. If it ends up with a non-zero value in the stack, that's going to return true. And so here you can see we're simply just put the counter out. It was 3 when we started. Now it comes up and it is 4, and it's in the global section. And the next step is going to just take and get that so it comes back on the stack. So you have a value here and now a return true. And that's it for that debug session. And now that's good, so we can go ahead and send the transaction, and that will go ahead and get approved and then come back out to our main line. And, oh yeah, we want to print the global state. So there it is. It's getting it out of the transaction. And that is the first one. And then the second one I've got here actually reads it from the account information. So this is going to print that off. It's going to be the same information. The first one came out of the transaction. Now it's on the account. So you can see the value there for the counter is 4, like we had specified. Now the good stuff, right? I'm going to update this application, and that's going to use the update method with the new program that got passed in that has the access to the local state for the account, the user account. All right, now let's call this application a second time with this updated version here. So we got our file. We're going to go invoke our debugger, come back out here again, do the inspect. And now you can see the additional fields. So now when I go over this, what you'll see is the values change for, oh man, I hit run by instead of step, but the idea here, what you would have seen is the counter actually increase for local state. And we'll see it actually in the application because we're going to print that out. So all is not lost. And this is going to print the local information down below, what you're going to see next. There's the global state followed by the local state. So now you can see that the local state has been updated, and this is the new counter, the local counter, and that is the value of 1. So we incremented that, that value. Again, you can read it from the transaction right after it happens, or you can read it from the account. So we're going to close this out. Then you can opt in and you can resend it, and then you can delete account. So those are the functions that you would see in this particular example. Let's go back out to the deck and talk about one more thing here. Indexer. So if you ever want to query the blockchain, this is the way to do it. It's very rapid, very quick, and this is the way it works. You have the actual Algorand blockchain here on the right, which has the algo daemon process. And all this does is it feeds off of this process and it populates a Postgres SQL database. This could be, you can have this anywhere. This is accessible through all the SDKs. There's a REST API for it, and basically, this is how you do your queries. So, you know, when you write a game application, for example, maybe you want to have tokens in the game and you want to build a leaderboard. Well, you do a query. Give me all the assets for this particular account, or give me any accounts that have this particular asset. You can do either one of those queries. And that's how you do it, is with Indexer. You can build your own. This will take about 3 days. You do need to have an archived index node in order to do that. Or you can use a service. A few services are out there right now, PureStake or Explorer.io. Also, I understand things that come with our sandbox will support Indexer as well. So that will be a third option that is right out. It will be out pretty soon. All right. So in terms of the actual code to access something like this, let's go over to our last language of the day, JavaScript, equal opportunity employer. So this goes ahead and retrieves the info. This is an example using the PureStake indexer service. If I go ahead and just run this JavaScript program, to get an idea for what you can do here is you have a lookup by account ID, a very simple query, but it brings it back really, really quick. And then you can see that information print off down here in the debug console for that account information that you see right there, listed account information, and that gets printed off. Other examples here would be, this is what I mentioned where you can do a search counts on the particular asset index. So that's a good query, right, to build leaderboards. The last one I'll show you here is actually one that you can actually feed in a timestamp to do the query. And that's going to go ahead and for that particular address, give me the transaction. You can give a range, a start time and end time if you wanted. And that's a great way of looking up transactions. Okay. Getting in the home stretch here. This is our developer newsletter. If you didn't sign up for this one yet, I would sign up right now because we're going to do a drawing in a few minutes on this. And community projects. We have a community page up on our dev portal site. This is under the feature documentation right there that I showed initially. Many SDKs are starting to enter the scene. You got the Algorand SDK for IoT. You've got Algorand, provides some JavaScript functionality, API wrappers. You've got Algorand IDEs. So a lot of good things happening there. All right, folks, this is the last chance to enter the newsletter contest. Again, we're going to do a $100 Amazon gift card draw in a few minutes. The Algorand Foundation, I want to make you aware of, there's two sides to the two companies here. One is the Algorand Foundation. That's the money side of the house. Jason and I both work for the Algorand Inc., the technology side of the house. And these are programs that the foundation has. There's a developer rewards program. So if you do create an SDK, you can put in for like developer incentives rewards. You can also get rewards through the ambassador program, developer ambassador. You can write tutorials and then get they call that DevAms for short. We have some grant programs for larger projects as well. So if you want to become an ambassador, there's an ambassador rewards program, and you do that by contacting Stephen at Algorand Foundation. This is the link for the PowerPoint deck. I'll throw that in the chat window as well. And I'm going to throw in a session evaluation and be very grateful if you can fill that out, both of these, when you get done. Actually, the PowerPoint you can download right now, then the session evaluation for when we can get done. And I got a couple of great videos that are in the deck here too, one on Teal, one on the proof of stake. And lastly, where's the code? So there's two areas. One I pointed to in our feature guide. You just click on the link at the bottom of the article. That'll bring you to Algorand docs. And there's an examples page. Also, there is a hackathon instance. That's where that stateful Teal currently resides. The stateful demo I just showed you in Python. So in summary, we looked at a lot of great use cases, a lot of good scenarios for building blockchains. We have layer one features galore, all right? All these great capabilities for developers in the way of Algorand and standard assets. You know, atomic transfers is key to all these solutions that you're building. So really get a good handle on that. And then you can really build some robust solutions and scenarios on the Algorand blockchain. And also we looked at assets and creating your own tokens. Again, another very powerful feature. This has all the benefits of a native algo on the blockchain. Things like prevention of double spending or overspending, and all those features are built right into ASA. And then we looked at Reking is another great key. The developer tools, lots of tools out there, and more are on the way.